Hello students, welcome back. In this video, we're going to introduce our core mechanic here for light steps, and that's platforming. Our player is going to be able to move and jump vertically into the air, being pulled down by the force of gravity. And this will hopefully allow us to jump and move from one platform to another. In order to do this, we sort of have to revamp our entire movement system, because before we were just simply updating our player. We were pushing it in one direction to the left or pushing it in a direction to the right. But now we will have unique movement in both the horizontal X direction and the vertical Y direction. And in one of those, we'll speed up and slow down, and that's the vertical direction, because gravity will slow us down as we're moving up, and it will speed us up as we're falling down. So let's head to the computer screen and we'll dive right into this lesson on platforming. So I have lesson 3's starter file here, our core mechanic of platforming, and whenever we land on a platform, we are actually going to light that platform up, hence the name of our game, Light Steps. So I have our starter file open here in vscode.dev, but I'm also going to minimize this file and open it directly. So I'm going to click on my Light Steps folder. I'm going to come over here to lesson 3. And we'll open this up. And let's see what we've got here. So here's my player. Perfect. If I hit space or the up key or the W key, nothing jumps. So that's not working. But it looks like I can go beyond that platform now. So I have the freedom to leave this platform in the horizontal direction, but I am bounded by the edge of my screen. So eventually we're going to want to have some gravity so that if I get over here, I fall down, and then I have to somehow figure out that I've collided with this platform and stop moving. So let's head over to the computer screen. Let's dive right in. So mission 1 says we have to add our jump constants. So we're basically adding a brand new system here, like a physics-based system. And anytime we add a new system, I like to always start by going to our student edit zone and seeing what we have to work with for this system. So if we look, here are some constants for our player. Here are some constants for the different platforms we created. And now I have some constants for our jumping system, our physics system. So I have 3 new variables. Think of these like knobs that we can turn and tweak to change how the system feels or plays within our game. So I have a variable called player jumps velocity or player jump velocity. I have a variable called gravity, and I have a variable called max speed. So they are all set to 0 right now. Not ideal values. Okay, so let's start with gravity. All right, so gravity is going to pull our player down, and the rate at which they pull us down is going to be pixels per frame squared. So maybe how many pixels will they pull us down per frame squared. So we're going to make this, I'll just make it +1. And so I'm going to make it positive because as we go down in the Y direction, this is a Y value of 0. And as I go down, my Y value gets bigger and bigger and bigger here in our game window. So we're going to have our gravity be 1 pixel per frame squared. And we're going to set a max speed. So that gravity is going to speed us up. It's going to make us fall faster and faster and faster. So each interval, we're going to fall a greater distance and a greater distance. But I'm going to set my max fall speed to be 20 pixels per frame. So I won't fall faster than that. We'll cap it off there. Think of this like our terminal velocity. But then I got to set my player's jump velocity. So both of these values are for downward motion, and they are positive. So our jump velocity is going to move us up the screen. So that means I got to make it the opposite direction. So I got to set it to be a negative value. And I'm going to set it to be, let's make it -20. Okay, so with those constants set, if we look over here, can we jump now? Well, we still don't have any jump capabilities, so we got to do a little bit more. So let's go to before we go to mission 2, let's see what else we got to work with here in our jump system, our physics system. So any new colors in our color palettes? Doesn't look like it, so no new colors. Any new game variables? I think we've got a new game variable here called lit platform index, and it's currently set to -1. So we said that we were going to light up our platforms when we stand on them, and these are the 6 platforms that we light up. These ones are sort of like our safe platforms that aren't going to light up at all. So if I landed on this green one, it would light up, or this purple one, it would light up. And so if you remember, when we created our platforms, so I'm just going to work through some of our data structures here. When we created our platforms, where are we creating our platforms? our platforms took in an index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the indices of our platforms. This is 0, 1, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9, and 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And so we're going to pick the lit platform index. And so right now we're defining this new variable as -1, which means we're not picking anything right now. So for instance, if I had this set to say 2, well then it would be 0, 1, 2. We would say we should light this platform up. And we'll look at that functionality here, I think maybe towards the end of the video. But let's also note that our player object looks a little bit different. So, and I'm just going to open up maybe the lesson that we did from lesson 2. Let's open up lesson 2. I'll have it right here so we can look. Let's look at what our player object looked like. See, before our player object only had 2 properties, X and Y. Well, now we got a lot more properties. So let's look at what we got. We have a Vx and a Vy because we said we're going to have to separate our motion into 2 dimensions. Our player can move horizontally with a Vx, but eventually once we get our jumping system moving, they'll move vertically with a Vy. So we have 2 properties for that. We also have a property called on ground, which is keeping track of whether or not the player is on the ground, on a platform, and we initialize it as false. And then we're keeping track of their current platform index, and that's set to -1. Well, that would mean, hey, they're not currently on a platform. Well, I bet when we reset our player, we're going to change some of those values. So let's just go check. Let's go check this. So in reset game to defaults, when we restart our game, you can see we're emptying our platform array. We're setting our platform index, the lit one, back to -1, which means don't light up a platform. We're spawning all new platforms, and then we are resetting our player. So let's go to reset player, and let's see what we're doing in here. All right, const safe platform is equal to platforms player start platform index, which is variable, is a constant 6. And then we are positioning the player based on that platform. And we're setting their Vx, their Vy to 0, and we're setting their on ground attribute to true. So we're saying, hey, you are now on a platform. And we're storing their current platform index as the starting platform index, which is 6. Hey, let's just go do something. If I change those numbers, I should probably be able to change where the player exists. So I'm going to go to the student edit zone way up here, and I've got player starting platform index. Let's change this from 6 to 2. We said that 2 would be 0, 1, 2. Our players should start up here on the blue platform now. Hey, and there they are. They start up on the blue platform. All right, so let's do 0, 1, 2, 3. Let's do 3. That should spawn them on the yellow platform. Let's just take a look. Is this working? All right, so now the player has a way to keep track of what platform they're on based on that current platform index. Now, we want to start them smack dab in the middle, though, so that's going to be at platform index number 6. All right, so with that overview of our updated data structures, primarily for the player, let's go to mission number 2. Mission 2. So we have an overview now of what we're working with in this new revamped physics system to create our platforming movement. Mission 2 is all about jumping. So it says apply jump when the player presses a key. Allow multiple jump key options. Okay, so this finds us in a function called update player jump. Well, we also got a function a little bit lower called update player physics. And then check player platform landings. All right, so these are all new functions that we got to work. Ooh, check player fall off screen. That one doesn't sound too good. So we got new functions here that we're going to work through in these missions for our physics system of platforming. We're going to check to see if the player has fallen off the screen, if they have fallen to their death once gravity is in effect. Woo, all the way down. Then we're also going to check to see if the player has landed on a platform. Because if they land on a platform, we should probably stop them from falling. Okay. And then we are updating our player physics. So we said jumping. This motion is all physics-based motion. We're going to update our player's jump, get input direction, update player move. Okay. And look here, we've got update player. This function has a lot of stuff in it. Inside update player, we are updating the player's horizontal movement with update player move. We're updating their jump movement, their vertical movement. We're updating our physics. We're checking to see if they landed on a platform, checking to see if they've fallen off the screen. And we do this every single frame of our game because update player is getting called I'll go to it, in our default P5 draw function. So this function right here gets called every single frame. If our game mode is equal to play, we are updating that player. So let's now go to update player jump. It says apply jump when the player presses a key. Allow multiple jump key options. So it looks like we're creating a variable called jump pressed, and it is currently set to false. Well, that means we're not jumping. But what if we do want to jump? Well, we maybe set it to true. But if we hard code it to true, that means we are always jumping, and we don't want that. There could be some times where we just simply don't want to jump. So what we got to do is we got to ask a question. We got to ask a question that is sometimes yes, sometimes no, sometimes true, sometimes false. And the question is going to be, is a specific key being pressed? And so we are going to use a couple of different keys here for jumping. So I'm going to say key is down. Is that key being held down? If it's being held down, then we are going to indicate that we are jumping. And I'm going to type in a key code of 87 because that is the W key. Or I'll do key is down and I'll type in the phrase up arrow because we can use the W key or the up arrow for a jump. But there's something about this type of game. We need another key for our jump button. So we're going to have three options. Key is down, and that is going to be key code 32. And I know you're hoping what it is. It is the space bar. The space bar is going to allow us to jump. And then we look. Okay, we say, hey, if jump pressed, so if this question resulted in yes, and our player's property, on-ground property, is true, meaning they are currently on a platform, we're going to target their vertical velocity. So remember, we separated our vertical and horizontal velocity, and we are going to change it to -20, which means move them up and set on-ground equal to false. Let's test it. So now that we're in here, let's take a look. I'm going to refresh the page. I'm going to press the space key, and we are going to, unfortunately, do nothing. Rats. Well, why not? Their vertical velocity should be -20 right now. We just set its vertical velocity to -20, but I don't think we are yet doing anything with that negative velocity because what velocity needs to do is change position. So velocity changes position. In fact, why don't I just go to the whiteboard here and let's just write that relationship down because it's super important for us to understand in this platforming game that is reliant on physics. We'll say that velocity or speed in a given direction is equal to the distance we are going to travel, so our change in position, over our time interval. So that's really important here, okay? So velocity is going to create, and I'll just call this distance over time. For right now, I'll call it a change in distance, change in position. Velocity causes, we'll say velocity causes a change in position. And we might say, hey, we could also change our velocity. Like we might speed up or slow down. The thing that causes our change in velocity is known as acceleration. So acceleration causes a change in velocity. Now, our acceleration, we're going to see it in a little bit here, is got a special name. Our acceleration is called gravity. So gravity is the thing that is going to accelerate us. So let's go see if we can apply our velocity that we just set to change our position. So let's see. Let's go to, I don't know, should we go to mission number 3? Hey, mission number 3 finds us in a function, update player physics, where, hey, we're going to have to do mission 4 here too. It says update gravity and velocity movement. So remember, these are physics relationships. Mission 3 says move the player using velocity values. Update vertical position based on motion. All right, so in here, it looks like we're taking our horizontal position, player.x, and we're adding to it our horizontal velocity, so player.vx. All right, so I'm going to actually open up our previous file here really quick because I want to show you something. Before, in our previous file, we were doing all of our movement right here in update player move. So in update player move, you can see we were changing our x position by adding our velocity. But now we're removing it from that function. And let's go look at what update player move is doing. So update player move is now actually doing what? Well, we're getting the direction we want to move in. That's our dx. Remember that? It was going to be 0 if we're not moving, -1 if we're going to the left, +1 if we're going to the right. And we're multiplying it by our speed, and we're setting that to our player's horizontal velocity. We're just updating the velocity. We're not updating the position here anymore because that position is going to get updated in our player physics function. So we're taking our position and updating it by our velocity in our x direction. And that seems like it's working really great. I mean, I can move horizontally. Well, let's do something similar to update our vertical position. So player.y, and we are going to update it by adding our player.vy, our vertical velocity. Let's take a look. Let's see if we now hit space, will we actually change our player's vertical position by the vertical velocity, which we set to -20. Here we go. 3, 2, 1, blast off. Oh man, it's getting old. I really want to jump. Well, I think there's one big problem here. Eventually, we are going to be calling these things like check player platform landings and check to see if we fall off the screen. In check player platform landings, you can see we assume that we are no longer on the ground. So we set player.onGround equals to false. And we haven't finished this. So we never fully set it back to true. So our program thinks we are not on the ground. So that's a huge problem here. So let's fool it. So we're going to come back to update player jump, and let's just remove that check to see that we are actually on the ground. So now, as long as we press the jump button, we should launch upwards. And this is our test to see if it is correct. Are you ready? And 3, 2, 1, jump. Hey! Come back, please. Why don't you come back? I miss you. I miss you, my little fried egg player. Well, the fried egg player is never going to come back because we set their upward velocity to -20 and we've never changed it. So the thing that is going to change it, the thing that is going to slow that velocity down is in mission number 4. Mission number 4, we have to apply gravity to the player each frame. Now we said gravity is our acceleration, and that acceleration will change our velocity. So we're going to target the player's vertical velocity, player.vy here in our update physics. And we are going to add to it the value of gravity. I think gravity was +1. So right now, vertical velocity, when we set it, was -20. We went flying up. So when we add in the positive direction, we add 1 to it. -20 plus 1 is -19, then -18, -17, 16, 15, 14, -13, then all the way to -3, -2, -1, and 0, which is when we stop. And then gravity is going to keep adding. So then it's going to become +1, +2, +3, and we're going to speed up moving down. But we don't want to speed up forever and ever and ever. If you remember, we said there should be a maximum speed with which we fall. So we're going to constrain our player's vertical velocity. We're going to say, okay, we're going to set the min value here. We're going to call min, and we're going to say, pick the smallest of these two values, player.vy or max fall speed. So if player max fall speed is set to 20, so if player.vy would have become 21, well, what's smaller, 21 or 20? It's going to be 20, and we're going to keep that vertical speed at 20. Let's test this. Let's see what happens if I run the game. Whoa, I just fell right through the screen. Well, let's jump right off the beginning. Jump, jump. Hey, I can just kind of like levitate here. I can just keep jumping. Hey, that's kind of fun. Now, the reason why I can just keep jumping over and over again is because I can do like mid-air jumps. How cool is that? It's because we removed that check in update player jump that we were on the ground. So let's actually add that check back in. So I'm going to go back to update player jump, and we had removed a check right here in this question. If jump pressed, if we press the jump key, and, so we got to put the and sign, double and sign, our player objects on ground property is true, then we'll jump. So now if we refresh the game, we'll lose that ability, and gravity is just going to pull us down. See, now we just fall right to our death, which is not good. That's not good at all. So thankfully, we got 4 more missions we can work to fix on this. Let's look at mission number 5. We are in check player fall off screen. Remember, all of these functions are getting called from the update player, right? All of these new functions that go into our physics system are getting called inside update player. We update our move, our horizontal movement, update our jump, our vertical movement, update our physics, which actually repositions us based on our new values, and then we check for platform landings and falling off screen. So right now, if our y value, the player's y value, is greater than the height of the canvas, meaning our y value, which is the top of us, if it has gotten bigger than the height of our canvas, we are officially off the screen. We're going to say, hey, the lit platform index, you are not going to light up anything right now. We'll set it to -1, and then we want to reset the player. So let's take a look at how we're going to do that. Well, it's kind of neat. We actually have a function called reset player, right? We already looked at it. It's going to reset the player. It's going to reposition them. So we'll just go to it. A little hint, if I double click, I can highlight that. And if I hit Control F, it automatically appears in my search bar. So here's my reset player function. It's going to reposition the player for me and set me back on the ground. Okay, so let's check it out. Let's see what happens now. If I refresh the game and run this, I fall, I fall, I fall. Oh my goodness, it's just this endless loop. I just keep restarting only to fall to my doom, Well, that's because we got to ensure that we actually collide with one of these platforms. When I hit a platform, I got to set my velocity to 0. I should no longer fall if I hit a platform. And so let's go to mission number 6. Mission 6 finds us in the check player platform landing function. And we got a lot of really great stuff here. First off, it says, hey, if your vertical velocity, the player's vertical velocity is negative, if it's less than 0, just get out of this function because you are moving up. And if you are moving up, we're not going to collide with the platform because you're jumping upwards. We're only going to collide and stop us if we fall down. So if we are here and we jump up, we could potentially jump up over that platform, and then when we fall, we'll collide with it. So that's our first check. And then it looks like we have some neat variables here. We got the previous player bottom, the current player bottom, the player's left, the player's right. And then for all of our platforms, so this is neat, we're looping through every single platform that we have for const platform of platforms. So if I have, I have 10 platforms, so I'll say plat 0, plat 1, plat 2, plat 3. We'll just keep going. We loop through this. The first time we go through and do our code, platform is plat 0. The next time, platform is plat 1. The next time it's plat 2. The next time it's plat 3. So we can run all of our code for everything in our array. We get the top of our platform, the left side of our platform, and the right side of our platform. And then we are going to see whether or not the player has landed on a platform. So it looks like we've got 2 variables here, crossed top and overlapped X. And so we got to talk a little bit about how we're going to determine if we have landed on a platform. We are going to check for downward collisions here. So to help with this, I'm going to go back to my whiteboard because I think a picture here is going to be amazingly helpful. All right, so the first thing that we'll say is, we really got to check for 2 things to see if we're going to collide with a platform. First, if this is my platform here, the player, they got to be aligned horizontally. So if the player is all the way over here, some distance away in the X direction, no, we're not going to land on the platform. We're just going to fall. And if we're all the way over here, away from it in the X direction, we're just going to fall. But if we are somewhere in this zone, bloop, bloop, then when we fall, we have a chance we're going to hit the platform. So we got to overlap horizontally and we got to overlap vertically. So let's talk for a bit about this vertical overlapping. So I'm going to draw a handful of pictures, a handful of scenarios to help us get the idea of what's happening. So we'll draw 3 scenarios. So I'll draw one over there and one in the middle. So I'm going to put a platform in each case. All right, so there's a platform. Here's a platform. And here is a platform. And so now imagine I have my player. And so here is my player. And then in the next instance, my player falls. And then in the next instance, my player falls. And in that instance, my player crosses over the platform. So what we need to do, if you remember the variables we had, we're keeping track of the player's current bottom. So the current player bottom. So I'll call this CPB, current player bottom. And in this snapshot, here is the current player bottom. And in this snapshot, here is the current player bottom. But we're also keeping track of the previous player bottom. So imagine if I just extended this line, a line over right here, we're keeping track of this height as well. We're keeping track of previous player bottom. And now, if I draw this over into the next frame, we're keeping track of this height right here. This is our previous player bottom. We're also keeping track of the top of our platform. So this is our top of the platform. This is the top of our platform. And this is the top of our platform. I feel like we should probably draw one more picture, because right here, this is where the magic is going to happen. This is where the collision occurs. But if we don't nail it right, our player could still potentially fall. And if they fall more, let's see what happens. If they fall more, they're going to fall here. All right. And so here we would say, okay, this is our current player bottom. And here is our previous player bottom. So this is no good. And so if we look, there is a special condition in this scenario, right? Here we're falling, but we haven't yet collided. We're still falling, but we haven't yet collided. This is magic. This is the place we want to be. And then this is no good. We'd be inside of the platform. So we need to check a certain condition. We need to check to see if, so we'll ask a question, if our previous player's bottom, so if our previous player bottom is less than or equal to the top of our platform, right? So here we are. We are not yet all the way down to the bottom of the platform. And we got to have another thing be true. And is our current platform bottom right here, is that greater than or equal to the top of our platform? If those two things are true, right? If that's true and this is true, then we have hit a platform. We have collided. And that means we have to set player.vy equal to 0, because we no longer want to be falling. So let's take that idea and let's implement it here into mission number 6. So mission number 6, it looks like we've already got the overlap X. So we're already doing the X, the horizontal motion, correct. But it looks like we got to just fix this vertical motion. So let's write in using the variables that we have up here. All right, so we're going to check to see if the previous player bottom, so tab for autocomplete, is less than or equal to platform, what is our variable? Platform top. All right, so there is the top of our platform. And we got to make sure we have the and here, is current player bottom, is our current version of the bottom greater than or equal to our platform top. If that is the case, then that means we have just crossed over. And if we cross over, this question is now true. So let's look, because then it asks us to do something else. If that question evaluates the true, if we were aligned up in the horizontal direction, we'll maximize this so we can see it. If we were lined up in the horizontal direction and we fell and we had the correct overlap, we are right here now. We need to do a few things. We got to stop our player. We got to snap them. We don't want the player to live in the platform. We got to kind of move them back up, right? We got to position the player back up and then stop them. So mission 7 says, let's snap the player to the platform landing and stop falling and place the player on the top. So the first thing we'll do is let's snap the player's position. So I'm going to take the player's vertical velocity and I'm going to set the top of the player equal to our platform top. Platform top. Now, there's only one problem with that. If I set their Y position equal to the platform top, if we come over here, I'll show you what that problem is. The Y position is the top of the player. So the Y position would be taking our platform. So here's our platform. Right? This is the top of the platform. And we are taking the player's Y position. That's the top of the player. And we're putting it right there. Oh no, so our player would exist in the platform. Well, we need to actually move them up or subtract their Y value, and that is going to be the player's size. So we got to subtract the player's size to move them up so they land on the platform. So we'll do player.y is equal to platform top minus player size. Then we want to stop them. So we're going to say, hey, player.vy is equal to 0. Let's take that vertical velocity and set it equal to 0. And then they just landed on a platform. So if you remember, they have a on-ground property. We should probably set that to true because they just landed. All right, let's check this out. Let's see if our whole jump system is now operational. All right, so I'll refresh the page. Hey, I'm not falling. Oh, hey, I did fall. Hey, I can jump. Hey, gravity works. Gravity works. It pulls me down. If I fall off the screen, I reset. I'm no longer repeatedly falling to my death, so that's great. I can hit the space bar or up to jump. Ooh, look at that. I jumped through that platform, and then I only land on my way back down, so that's good. I hold the keys, I can do repeated jumps, which is exactly what I want to do. Ooh, that's kind of fun. All right, so this is working wonderfully. Gravity is working, our jumps are working, and our platform collision check is working as well. There's one last thing I want to do, and that's I want to light up some of these little platforms when I jump on them. So let's go look at mission number 8. Mission number 8 is in our check player platform landings again. It's right below. We have just landed on a platform, right? This means we have landed on a platform. We just stopped our player from moving. So now we want to light up a given platform. And so if we look here, it says if platform.isSafe. So our platforms have a couple of properties to them. You stay here. I'm going to go look at our platforms. When we create a platform, it looks like they are taking in an isSafe property. So are they a safe platform or are they not? So let's look here. Our bottom row and top row, that's like our memory row. They are taking in false. They're not safe. And then our safe network, our bridges, are taking in true. So these are all safe platforms. These are never going to light up. Only our non-safe platforms are going to light up, because if we jump on the wrong one, it's going to be dangerous for us. So in mission number 8, if that platform is safe, we don't want to light up anything. So if we don't want to light up any platform, I'm going to take lit platform index, which is that variable we looked at, and to not light up anything, we'll set it to -1. Otherwise, we've landed on a platform that is not safe. It's one of our memory platforms. So I'm going to take lit platform index and set it equal to, the current platform that we're on, the current platform that we collided with, it has an index property. Remember, these are, let's just go back and look. Oh, these are index 0, index 1, index 2, index 3, index 4, and index 5. Let's set our lit platform index equal to the current platform's index property. And so now we know which platform we want to light up. Let's check it out. Let's see. Is that going to light up our platforms for us? Let's jump. I want to light up the green one. Boom. That looks really great. And it lights up for a nice amount of time. Hey, blue. Red. Oh, this is cool. Yellow, green, purple. How fun is that? So our platforming here is working wonderfully. Okay, so you may be asking yourself, how do we know to light them up? So like if I just stay here on the red platform, it's lit up, and it will stay lit up until I land on a new platform, okay? And so let's just go, I'll show you that really quick here, and that's going to be in our draw function. So down below, if I just go down to our draw scene where we're drawing our platforms, you can check to see for every platform that is in our array of platforms, I am checking to see if our platform's index is equal to that of our lit platform index. And if it is, I do some things to make it look lit up. So I set the alpha, or the transparency, to 255, which is essentially 1, which means make it so you can't see behind it at all. Right now, these are all transparent. And when I land on one of them and its index becomes the lit platform index, I set its transparency to 255, or don't make it so you can't see through it at all. And that's why it looks so vibrant. All right, I think this is a wonderful place to stop. I am really happy with how this core gameplay mechanic is coming together. Platformers are one of my favorite game genres, and puzzle games are probably one of my favorite game genres too. So a puzzle platformer that we're building here is going to be a lot of fun. Hopefully, in the next video, we'll begin to implement some of the puzzle aspects of our game. You can already see them forming. We have platforms that are going to light up, and we have to follow and jump on all of the platforms that have lit up in a given sequence. So hopefully in our next video, we'll introduce something that the player has to manage or remember in the form of a sequence of platforms. So I'll see you in that next video.